So today, Joseph asked me first to give you an introduction about the concept and the technology of filtration before showing how it works in our ecosystem. So when speaking about filtration, filtration is a way basically to eliminate chemical pollution in the lab. So traditionally, the pollution is just ducted out. So we are not solving the problem, we are just passing the problem to somewhere else. So with the traditional duct, we just take the pollution and we just kick it out of the building, and it's somebody else's problem. But with filtration, we really have a solution because we capture the chemical pollution right at the source, and we circulate clean air back into the laboratory. So as you know, it has many advantages, such as no need for ductwork, so also no connection to AC, no consumption of makeup air electricity. Also, it gives a greater flexibility. And so this filtration technology can be applied to many different needs in the laboratory. So, of course, for the chemical handling, which is, let's say, the most traditional usage of filtration, it's on fume hoods. So, by mounting the filtration column on the enclosure, we are able to directly treat the pollution from chemical handlings right at the source. Also, filtration is used for storage because the product, when it's not used, still continue to emit vapor, and it's a source of pollution in the lab, so it still needs to be treated. So that's why ventilation for storage cabinet is one solution to treat the problem. But also ventilation can be used to clean the air in the lab itself. So it's what we call a second line of defense. So the air in the laboratory can become polluted if for instance, somebody spills some chemical. There is a leakage due to ill-maintained appliance or equipment, for instance. And so filtration can also be a solution to clean the air in the laboratory. I will show you this later in my presentation. But here I would like to illustrate the different type of filtration by taking as a reference point the fume hood. So our fume hoods, they are modular in the sense they can be configured in a different way to combine different type of filtration. So there are two main type of filtration. So there is the particulate filtration, and there is the carbon filtration. So the particulate filtration, which is meant to filter particle, powders, dust, etc., is done through HEPA filters. And the molecular filtration, so the one that use carbon filters, is meant for pollution coming from liquid chemicals that emit vapors. So we can see that it is possible to configure the column in a way to cover different needs if we only deal with liquids or if we deal with liquids and powders. But to tell you here that really the core expertise of Erlab lies in molecular filtration. However, HEPA is also one important type of filtration. So I will start by presenting briefly the so-called particulate filtration, the HEPA filters. So how it works, basically it's a network of fiberglass that is arranged randomly and that will physically prevent the particle, the dust, but also bacteria or even viruses to go through the filter. They will be physically blocked by the filter. So this technology has been around for a long time. So the mostly used type of filter in our industry is the H14. So I will explain what is H14. So H14 refers to the efficiency of the filtration. So we can see that the H40, which is the type of HEPA filter we use the most, basically will filter 99.995% of particle which size is between 0.1 and 0.2 micrometers. Why this specific size? To make it simple, we take the size of the most difficult particle to filter is called the most penetrating particle size. And we use the most difficult to filter as the reference point, so we can tell the efficiency. So if the particle is bigger or is smaller, it will be retained better than this one. So retain here that the norm is H14 and the filtration efficiency is 99.995%. But now let's continue with what is really the core expertise of Erlab, which I mentioned earlier, which is the molecular filtration. So Erlab has been the pioneer in this industry and has dedicated a lot of research and a lot of time to develop this technology. So the goal is to filter an increasing number of chemical, also to increase the filter lifetime and the capacity. So next to the filter itself, it's important to develop high performance detection system. So our lab has been working on developing such a system for a very long time. And also to develop a remote safety control system. I will speak later about the eGuard system, but the goal of all this is to offer a product that can replace the traditional ducted fume hoods, which are complicated and very energy consuming, by our technology, which is more simple to use, more user-friendly, and more flexible in the lab. So when we speak about molecular filtration, it's maybe good to understand how it works. Probably most of you already know, but it's a good opportunity to refresh the concept. So as I mentioned, the particulate filtration with HEPA filter is a physical process. But for molecular filtration, because the size of the molecule is too small to be trapped by a physical process, it's made by a chemical process called adsorption. So the molecule in the polluted air will be adsorbed by the carbon molecule, and the air will be cleaned in this way. So we understand that carbon, the activated carbon, is really the key of this technology, is really the bedrock of this technology. and it's important to understand how it is made. So the activated carbon is the transformation of charcoal or graphite, which we can find in different sources. So in a natural state, basically we will cook the charcoal in a high steam temperature furnace, about 1800 Fahrenheit degree. And this process will reorganize the structure of the charcoal of the graphite. So instead of having layers organized parallel to each other, it will be a complex network of layers, which will increase the capacity of adsorption. And so the carbon will be saturated way less quickly. So the molecular filtration, as you may guess, is regulated by different standards, because you need to make sure that the carbon itself correspond to some specific criteria of performances. So there is this AFNOR NFX 15211 I will develop in the next slide. And here the message is to tell you that there are different types of carbon for different kind of chemicals. So at Erlab, we have developed 4 types of carbon filters, which are aimed at absorbing different type of chemicals. So each filter is composed of a unique blend of activated carbon, which will make them suitable for specific chemicals. So coming back to this standard, so the standard requirement. So the first one and the crucial one, of course, is the filtration efficiency. So Joseph just spoke about the PEL. And here we will test the efficiency of the filter by measuring the release of chemical downstream the filter. So basically we will measure the quality of the air downstream the filter, and to be qualified as an efficient filter according to this standard, we will need to find less than 1% of the PEL of the target chemical. So also these standards speak about the control of the raw material and the production of the filter. I will show you in the next slide how we do this at Erlab. Also the test, the way we test the efficiency of the capacity of the filter is rated by standard. And also the standard requires the company, the manufacturer, to give the list of the chemical filtered and the capacity of the filter. So at Erlab, for instance, we publish our chemical listing, which will list all the chemical retained by our filter and tell you for each specific chemical what is the filtration capacity. So telling you our filter can retain, for instance, 200 grams of this chemical, etc. So that's also a requirement of the standards, but very often manufacturers don't comply with this, or don't really make the test to be sure that what they publish in their list is accurate. So at our lab, we spend a lot of time testing the filtration efficiency and capacity of our filter for every possible kind of chemical we come across. And our chemical listing is very accurate. So in this aspect, so I mentioned that the standards speak about the raw material and the production of the filter. What makes Erlab very unique in the industry is that Erlab, we develop our own activated carbon. So basically, we work directly with the activated carbon producer, and we ask them to produce the type of activated carbon that is compliant with our own norms and standards. So here there are like a few pictures, so you can see the activated carbon comes from the shell of coconut. That's the first picture. In the second picture, you can see this big furnace where the coconut is cooked and it will be transformed into activated carbon. So what makes us very unique in this industry that we are the only company to really pay attention to the quality of the activated carbon we put in our filters. So not only we test them at the manufacturing site, but we also test them a second time at the Erlab here in China or at Erlab in France. So we control the quality of the carbon against specific criteria. So there are, of course, the international standard, but also some internal criteria we developed that are more stringent than the standard. So I listed here some norms, but I can, for instance, the ash content. So you have more than a specific percentage of ash. Or humidity content, so the carbon cannot be more humid than a specific limit, or the density, etc. Also, for the filters itself, there are many technical requirements to make efficient filter. So here I don't have time to develop all the points to explain what makes an efficient filter, but I will highlight the main one. So the first one is very important to have a constant thickness of the carbon, the layer of carbon. So in the way we produce, we make sure to have an homogeneous thickness of carbon in the filter, and not that the carbon grains are allocated in an uneven way, because it will impact the quality of the filtration. So it needs to be homogeneous. So we have developed our own procedures to make this and to control the quality of this. The second is the filtration velocity. Basically, the filtration will be optimal if the air stream happens at a specific and defined speed. So you need to make sure that when the air goes against the carbon grains in the filters, it circulates at the right speed and a constant speed. Of course, the design of the filter is important to ensure the fact that it's well sealed. But here the point is the sealing. So we took many years to develop a very efficient sealing that is completely prevents any leakage. So we have also developed a proprietary technology that ensure that the filtration column and the filter are completely sealed and don't release any chemical in the room, because it will be too bad to to suck the air with the fan, and have very nice filter. But if you don't have perfect sealing, you will just release chemical before even filtrating them. So sealing is very important criteria, and that's one criteria we test very often here at Erlab. So that's it for the introduction to the air filtration I wanted to give you. So Joseph, can I go to the next part of the presentation?
Yes, you may continue.
Yes.
Before that, is there any questions from the floor? Engineer Shahril?
No, it's fine.
Right. Okay. Thank you. Yeah, Julien, you can continue.
Okay. So I will speak about the Erlab ecosystem to give you an introduction. So I think Joseph already started and you're already familiarized with Erlab product, but here I wanted to show you what the notion of ecosystem means and how it can help you in the lab. So basically, the idea of ecosystem is that Erlab offers a comprehensive range of filtration safety device to protect the lab operator in every operation they do in the laboratory. So before I show you the product, I will just go quickly through this presentation to show you that basically there is a solution for every need in the lab. So the first one is when you do a chemical handling in the lab. So we offer the fume hood either with our Captor Smart range, mostly for routine experiments like quality control, etc. And we have our green fume hood range, which has actually higher capacity for filtration and can filtrate a greater number of chemical with one single filter. So this one is more suitable for non-routine work or for research and development handlings. So the second aspect you're also familiar with is the storage. So I have a range of storage products. So either the alone standing cabinet or the underbench cabinet to have the product always close to your operation. So the next aspect is the halo. So as I mentioned in the beginning of the presentation, it is about cleaning the air in the lab as a second line of defense. So this solution is not meant at filtrating chemical handling directly, but is meant to clean the air of the laboratory from the fugitive chemical emission that are in the lab. We also have real-time monitoring system called HaloSense. So the HaloSense will detect the presence of specific chemicals in the laboratory. So this device can be set in the laboratory, of course, but can be set, for instance, in a storage room or in an alleyway close to a laboratory, and will trigger an alarm when a specific level of chemical presence will be detected. So you can take solution to prevent possible issue. And the last aspect, which actually makes an ecosystem, so you see that we have a solution to covers all your needs in the laboratory. But what makes it really an ecosystem is that all those equipment, they are all linked to a single monitoring system called the eGuard app, which enables the user to control remotely the installation of its equipment. It can monitor and track specific performance criteria. So I will show you later. Also, what is specific to our ecosystem is what we call the smart technology, is that all our equipment in the smart range are equipped with the same so-called smart communication system, which give you alarms in case of issue through pulsing light, as you can see in the slides, but also through specific sounds, beep, and also, as I just mentioned, there is the possibility to track in real time the status of your equipment through the eGuard app. So here it's an example of the eGuard technology. So with the app that you can either download on your tablet, cell phone, but you can also have it on your computer. You can control the vital criteria of your equipment, like the air phase velocity, the filter efficiency, or the status of the fan, and you can do this in real time and see if there is any issue that requires to take some measures. So as I just mentioned, you can have it on your tablet, your smartphone, or your computer. So before going further in this presentation, I would like to show you the product in the showroom. So I will switch to my camera. So here it was the goal was to give you a presentation of the product directly in our showroom. So here we start with the fume hoods. So we have our smaller models, the 321s. So on the left side, you can see the 321s, which is specifically set up for weighing operation. So it is equipped with a HEPA filter and has a specific port for a specific dustbin on the side to facilitate the handling for the weighing of powders. So next to it, we have 3-to-1 with 1P, 2C, so with one HEPA filter and two carbon filters. So you can manipulate and do handlings with your chemical liquids and powder directly in the enclosure. So if I turn the image, I will show you the larger enclosures. So wait a minute, I'm moving in the lab. So here you can see the larger size enclosure. So you can see that it goes up to 4 filtration column with the last one here in front of the image. So it's the 714, which has 4 filtration column. That's our largest fume hoods in the smart category. And so the last one is the green fume hood. So here we have, sorry, I'm switching the camera. We have here the GFH, the green fume hood, which I mentioned is more suitable for research and development purposes. So it's equipped with a specific filter called Neutrodyne filter, which is our most advanced filter. And it can absorb a greater variety of chemicals than in the smart range. So it's particularly suitable for R&D operation, or if you use a large variety of chemicals. So next to the fume hood, as I mentioned before, we have the storage. So I will switch my image to the, sorry. Wait a minute. To the storage cabinets. So we have our models here. We have the 834 with 2 doors, and we have two 834 with 2 doors and one 1634 with 4 doors. So you can see here it has 2 different configurations, one with an extractable door and one just with a normal opening door. So if you wish, later I can show you the opening of the door closer. So next to this storage, we also have the 822, which is the underbench storage. So you have one model here with the 2 sliding doors, and we also have another model here with an extractable door. So I will just show you the opening very quickly. And the last, but not least, is one of the favorite products of Joseph is the Chemtrap. So the Chemtrap is a filtration column that you can directly mount on a flammable or a safety cabinet or even acid cabinet. So here we have one model H Smart. So this is for the storage product range. So as I mentioned, next to the storage, we also have the air purification range for the laboratory. I will develop in a few moments the different kind of halo product we have for the laboratory, but you can see it's mounted on the ceiling of the laboratory, or it can be installed also in other rooms. So it will purify the air from chemicals in the C configuration, or it will purify it from particle dust, bacteria and viruses in its P configuration. So I will develop this right after the product presentation. And so the last product I showed you before is the HaloSense, so the monitoring devices. So you can see here there are 3 models. So one for VOC, one for acids, and one for formaldehyde. So I will continue with the presentation, the slides, to speak a bit further about the halo I mentioned just now. So the halo is a product which I think is very important for the lab. So it will purify the air, remove the fugitive emission or odors in the laboratory. It will offer you 24/7 filtration, and it will increase basically the air exchange rate in your lab or in another room without increasing the consumption of AC or with a very low energy consumption. And it's very easy to set up, just mount on the ceiling, and very simple to operate. So here it was to speak about the new product we launched, which is the Halo P. So we have the Halo C, which was traditionally installed in laboratory. So one for VOC, one for formaldehyde, and one Chem Plus. And we have this new product, the Halo P, that can be equipped with HEPA or HULPA filter. And the Halo P is aimed at filtering and decontaminating rooms like offices, like patient room in residences, or like in healthcare facilities. So it can capture the bacteria and the viruses. So it is offering a good mitigation measure for the COVID-19 virus, for instance. So it will increase the air renewal within the room, and so give you further protection against the COVID-19 virus in your environment. So it can be installed in offices, in alleyways, in various different spaces. There are many applications for this product, not only the laboratory. I will just quickly conclude the presentation. So here it was just to tell you that also the Halo is equipped with the eGuard technology and enables you to monitor the units at distance. So that was it for my presentation.